All right, algebra, we are looking at 11.3, solving radical equations. So to do this, we're going to do the same procedure that we've always used for solving equations. We just need to isolate the variable. But this time in a radical equation, the variable is going to be located in the radicand. So in other words, it's going to be under the square root bar. So we need to isolate the radical on one side, and then we're going to square both sides of the equation. So for example, if we have 2 radical x minus 8, I want to isolate the radicand here. So I want to isolate radical x. So to do that, I'm going to start by adding 8 to both sides, which leaves me with 2 radical x equals 8. And now to isolate this, I'm going to divide by 2 on both sides. That leaves me with radical x equals 4. My next step then is to square both sides. Radical x times radical x gives me x, and 4 squared is 16. Let's look at a second example here. We're going to follow the same procedure. I'm trying to isolate the radical x. So first I'm going to undo the minus 3 by adding 3 to both sides, which gives me 12 radical x equals 3. Now to isolate, I'm going to get rid of this times 12 by dividing both sides by 12, which leaves me with radical x equals 1/4. Now for my last step, I'm ready to square both sides because that will undo my square root bar. And radical x times radical x equals x. And 1/4 squared, that means I square my numerator. 1 squared is 1. I square my denominator. 4 squared is 16. Now let's take a look at when we have an expression underneath the radicand. So I'm still going to try to isolate the radical here. So I'm going to start by undoing the addition. So I'm going to subtract 12 from both sides, which leaves me with 4 times radical x minus 7. And 28 minus 12 is 16. So now I'm going to undo this times 4. To undo that, I'm going to divide both sides by 4, which leaves me with radical x minus 7 equals 4. And now to get rid of my square root bar, I'm ready to square both sides. When I do this, what I'm really doing is radical x minus 7 times radical x minus 7. So remember, I'm squaring this expression to get rid of the square root bar. So that's going to leave me with x minus 7. And when I square 4, I'm going to get 16. So now I need to continue solving for x by adding 7 to both sides. And I get x equals 23. Now, if I take my solution and I substitute this back into my original equation for x, it should make my equation true. So if I put 23 in here, 23 minus 7 is 16. The square root of 16 is 4. 4 times 4 is 16, and 16 plus 12 is 28, so that checks out. Let's solve number 4. I'm going to start first by isolating my radical, so I'm going to get rid of this plus 9 by subtracting 9 from both sides. That leaves me with 2 radical x plus 6 equals 12. And now I'm going to undo my multiplication by dividing by 2. gives me radical x plus 6 equals 6. And now I'm going to square both sides. And that's squaring this is going to cancel my square root bar. So I end up with x plus 6 equals 36. And to isolate x, now I'm going to subtract 6 from both sides. And I get x equals 30. Let's substitute this back in up here to check it out. If I put 30 in for x, 30 plus 6 is 36. The square root of 36 is 6. Times 2 is 12. 12 plus 9 is 21. So we're good to go. Sometimes we're going to solve equations with radicals on both sides. So when this is the case, I always need to get rid of my square root bars. So I can do that. I can get rid of my radicals by squaring both sides, right? As long as I do the same thing to both sides, I'm good to go. So that gives me 3x minus 17 equals x plus 21. And now I'm going to combine my x's on one side and my constants on the other. So I'm going to subtract x from both sides. And that gives me 2x minus 17 equals 21. And now I'm going to add 17 to both sides. I'm going to move up here. That leaves me with 2x equals 38. And now I'm going to divide both sides by 2. And I end up with x equals 19. So let's substitute this in to make sure that it makes my equation true. So when I put 19 in for x, 3 times 19 is 57. 57 minus 17 is going to be 40. So I have radical 40 on this side. If I put 19 in here, 19 plus 21 is 40. So I have radical 40 equals radical 40, which is true. All right, let's do the same thing to solve number 6. I'm going to start by squaring both sides. That's going to cancel my radicals. So now I have 4x minus 12 equals x plus 3. I'm going to combine like terms by getting my x's together. It gives me 3x minus 12 equals 3. Now I'm going to add 12 to both sides to get my constants together. That gives me 3x equals 15. And finally, I'm going to divide by 3, so I get a solution of x equals 5. If I substitute 5 back in here, 4 times 5 is 20. 20 minus 12 is 18. I'm sorry, 20 minus 12 is 8, so we have radical 8. If I put 5 in here, 5 plus 3 is 8, so radical 8 equals radical 8. That checks out. Okay, the next thing we need to keep an eye out for is what we call extraneous solutions. So when we square both sides of the equation a equals b, it can result in a solution of a squared equals b squared. That is not actually a solution of the original equation. So all we need to do, if I end up with one of these extraneous solutions, is I just need to check each solution that I get in the original equation to be sure that there are no extraneous solutions. Because when I check, if it makes a false statement, then it's an extraneous solution that I don't need. So here are some examples. On number 7, if I have radical 4 minus 3x equals x, I want to solve this equation. So to get rid of my radical, I'm going to square both sides, right? So that gives me 4 minus 3x equals x squared. Now I see that this has an exponent of 2, so this is looking like a quadratic equation. So I'm going to bring everything over on one side. So I'm going to subtract 4 from both sides. And I'm going to add 3x to both sides. I'm going to do this so that I can factor this now and find my solutions. So I have it set equal to 0, and I know that factors of 4 is either 2 and 2 or 4 and 1. But I know that I need factors that add to 3. So if I factor this to x plus 4 times x minus 1, then that will get me back to this trinomial. So my solutions then would be -4 and +1. However, when I substitute these back in, I might find that one of these does not make a true statement. And if that's the case, then it's an extraneous solution. So let's start by substituting 4 in here. So I have 4 minus 3 times -4 equals x, which in this case is going to be -4. So -3 times -4 is 12, so this is 4 plus 12 equals -4. 4 plus 12 is 16. The square root of 16 is 4. 4 does not equal -4, so this looks to be an extraneous solution. So it's just an extra one that doesn't actually check out. Let's check to make sure that 1 works when I substitute it in here. So I have the square root of 4 minus 3 times 1 equals 1. So 4 minus 3 times 1 is actually 4 minus 3. 4 minus 3 is 1, and the square root of 1 does equal 1, so this solution works. So we would say our solution is just x equals 1. We don't need this extra or extraneous solution. Right, let's try one more like that. I'm going to solve number 8 to radical 6 minus x equals x, and I'm going to start by squaring both sides. So I get 6 minus x equals x squared. So I'm going to add x to both sides. Now I'm going to subtract 6 from both sides. And now I'm going to factor to solve. Okay, so that gives me solutions of -3 and +2. But let's check to see if we have any extraneous solutions. So if I substitute -3 back in here, 6 minus -3 equals -3. So 6 minus -3 is really 6 plus 3, which is 9. And the square root of 9 is 3, not -3. So this is an extraneous solution. Let's check when I put 2 in here. So that's radical 6 minus 2 is 2. 6 minus 2 is 4. Radical 4 equals 2, and 2 equals 2, so that checks out. So our only solution that actually works is x equals 2. And finally, we have our real-world problem. I'm almost running out of time, so I'm going to pause and solve this and then show you the solution. Okay, my equation is S equals 1.34 times radical L. S stands for speed in nautical miles. My speed is 8, so I've substituted. Now I need to isolate my radical. I'm going to do that by dividing both sides by 1.34. 8 divided by 1.34 is 5.97. And now I need to square both sides.